Welcome. This video is CC-BY-CN. All right, we are to the last of the identities, the half-angle identities. And there are two of them, sort of three if we include the tangent, which I often don't. I want to start off with a double angle identity that we already know. And if you remember, there were several versions of cosine of 2a, and we're going to use two of those versions. What I'm going to do with this one is I'm going to solve for sine squared. So I'm going to subtract 1. So I get cosine 2a minus 1 equals -2 sine squared of a. And when I divide by -2, pardon me, I'm going to bring that negative up top, and it's going to switch those. So the 1 will become positive, and the cosine part will become negative. So this gives us that sine squared of a is equal to 1 minus cosine of 2a over 2. And that is our first half-angle identity. And instead of writing it in terms of a and 2a, what we often do is we write it like this. It means the same thing. Just either way, this angle is exactly half that angle. We do the same for the cosine. So the other cosine of 2a is the 2 cosine squared a minus 1. So in this case, I'm going to add 1. We get 1 plus cosine of 2a equals 2 cosine squared of a. Divide the 2 out. That gives us cosine squared of a is equal to 1 plus cosine 2a all over 2. So our second half-angle identity, instead of writing it in terms of a and 2a, I'm going to write it in terms of cosine squared of 1/2 a equals 1 plus cosine of a over 2. Now, tangent, of course, is sine over cosine. And I do want to point out that to get sine by itself or cosine by itself, I'm going to have to do the square root. And when I do the square root, I need to keep in mind that it's plus or minus. And then I'm going to have to really pay attention to which quadrant are we even talking about. And we'll talk more about that in just a few minutes. So if I take sine over cosine, we end up with tangent squared of 1/2 a is equal to 1 minus cosine a over 1 plus cosine a. So here are our three half-angle identities. So let's use them in an example. Use a half-angle identity to write out cosine 5x squared. And all that's going to give us, here's our squared, is it's going to be 1 plus the cosine. I now need to double that, right? 10x over 2. And sometimes your homework will have you write it out like this. It really just depends on how it's being asked for, but this is usually fine. All right, next up. Use a half-angle identity to find the exact value of 112.5 degrees. Okay, well, I'd like to start out by pointing out that 112.5 degrees is in quadrant 2. And to be clear, sine is positive in quadrant 2. So this becomes positive square root, because again, sine is positive in here, in quadrant 2. And this becomes 1 minus the cosine of 225 degrees, because I have to double that. And if I go here to my unit circle, 225 degrees cosine, which is x, is the negative root 2 over 2. So this becomes square root of 1 minus negative root 2 over 2 over 2. And what I'm going to do to deal with that fraction in there is I'm going to multiply by 2 over 2. That gives us square root of 2 plus, because of the minus minus, root 2 over 4. And sometimes you'll be asked to write it where you can actually take the square root of the 4. So because we're not supposed to have a radical on the bottom. All right, next up. Example 3. Given the cosine is 3/4 and that theta is in quadrant 4. Now we need to really pay attention to that. Quadrant 4. So we want to find the exact value of the cosine of 1/2 theta. Well, no problem there. We have cosine squared of theta over 2 is 1 plus cosine of theta all over 2. Now, and we know theta, cosine of theta is 3/4. Two, and I can multiply the top and bottom by 4. 4 plus 3 over 8 gives me 7 over 8. Now, I would like to point out that it says that we are in quadrant 4. So when I take the square root, that's going to matter. But I want to point something out. Quadrant 4 is 270 degrees to 360 degrees. That's quadrant 4. So when I go through and divide for theta over 2, I get that my new range is 135 degrees and 180. This now makes it quadrant 2. So when I take the square root, which one is it? Well, because I'm in quadrant 2, cosine is negative there. So the cosine of theta over 2, which we just established is in quadrant 2, is now going to be negative square root of 7 over 8. And we need to fix that up a little bit. Negative root 7 over root 8, which is negative root 7 over 2 root 2. And I suppose I could rationalize that as well to give me negative root 14 over root 2 times root 2 is 2 times 2 is 4. All right. Next up, we want to find the exact value of the tangent of pi over 8. And we know that pi over 8 is in quadrant 1. And even when we double that, that's still in quadrant 1. So all the signs are positive in that case. And just a quick recall, tangent of a over 2 is equal to plus or minus the square root 1 minus cosine a for 1 plus cosine a. And so this means that a is pi over 4, right? We're going to double that, which means it's going to be the positive version of this because, again, we're in quadrant 1. So I'm going to write just the positive one from now on. So the square root of 1 minus the cosine of double that, pi over 4, 1 plus cosine pi over 4. Cosine of pi over 4, root 2 over 2. That'll be the same for both. Positive square root of 2 minus root 2 over 2 plus root 2. So half angle, not so difficult to use.